Time to move on to our first internal BGP peering. We're going to build that between routers 1 and 2. Router 2 down there at 172.12.123.2. And first off, though, I hate to start a video with a mistake. I'm making this one on purpose, so it doesn't count. Router BGP 100. What happens, let's say, if you're just typing right away and you try to make yourself the neighbor? Think that's going to work? What do you think is going to happen with that command? It's not going to work because you can't make yourself the BGP neighbor. You would be peering to yourself, and there's just something terribly wrong with that, not to mention illegal here. You're going to get a message that says can't configure the local system as the neighbor. So if you get that, it freaks you out the first time, like any error message first time. It's like, huh? And it just means that you put your own local IP address in, or one of your local IP addresses in. Now, let's try 123.2 there instead. There we go. I knew I had it in me. And then on router 2, we haven't done any BGP config at all. So let me move that back up. We'll start with router BGP 100 and neighbor 172.12.123.1 and our required statement about the remote AS. And we'll give that a few seconds to cook and see what happens. Usually just as I leave it, it ends up coming up. There we go. So it didn't take long at all. There's our adjacency change. Your neighbor is up. 172.12.123.1. Now, we know one command to see our neighbor information. And let's try it on router 2. Show IP BGP neighbor. We know that we can filter this by specifying the IP address of the neighbor, but we also know right now router 2 only has one neighbor, so there's no reason to do that. We know to look for the BGP state of established. We see that. We love that. This also shows you how long the adjacency or the peering has actually been up, what the remote RID is, etc. But wouldn't it be nice if we had a command that gave you just really what you needed to get started or double check your config without going, say, through, I don't know, the 5 screens of information that I'm showing you right now, most of which you really don't need at this point. And there is such a command. You'll be using this one much more often than you use the neighbor command, but it's a good idea to know both. And that is show IP BGP summary. And this is a great command. Now I've got a little hanging off because I make the font as large as I can to make it easy for everyone to see. The only thing hanging off there is a state of 0. And what we're really interested in, frankly, is the neighborhood and the AS and the up-down values. A couple of these we're just not concerned with right now, but you can see 172.12.123.1, and actually then you go over its AS100. We see it's V4 for version 4 of BGP, and it's going to show you how long it's been up or down, and we're up to 1.5 minutes. You also see message received there, incremented, message sent, hadn't yet, but those are our hellos. And if we go up to router 1, run the exact same command, that's going to give you the same kind of information. And you can see here state PFX received all on one line. I'm not sure why it's on 2 lines in the other one, but this works out for us. It shows you first off your local router BGP RID, which is 172.12.123.1, shows you the local AS number, and what we really like is from left to right, gives you your neighbors, the version of BGP you're running, the AS they're in. You can see message received and messages sent coming in and hopefully continuing to increment. And you'll also see that up-down value hopefully just keep ticking while it's up. That's all there is to an iBGP adjacency. And right now, we're going to start on using our loopbacks for BGP adjacencies. Now, so far we haven't done that. But here's why we usually do in production networks and why we'll actually change it to be using a couple of adjacencies in our lab. Now, there's nothing necessarily wrong with using physical interfaces to create BGP adjacencies. But in production networks and in labs, you're more likely to use IP addresses from loopbacks because physical interfaces can go down for a number of reasons, but the only way a logical interface really goes down is if someone intentionally deletes it or the entire router is unavailable. In that case, you have much bigger problems than lost adjacencies. Now, if you use loopbacks, you've got to include a couple of extra commands. And this is one of those things that catches you, but you don't want it to catch you on exam day. It's not going to, because you'll know first off, it's an odd little BGP role. Loopback interfaces aren't considered directly connected even if they share a common subnet. You'll need the iBGP multi-hop command when configuring iBGP adjacencies with addresses that are not on the same subnet. So you'll need that anytime you're using loopbacks. And when these addresses are on loopback interfaces, as they will be in this lab, the next one, you'll also need the update source loopback command. And we'll see that, and what it's actually asking for is the interface that you're using for your update sources, and that would be loopback 0, whatever you happen to number it. Now, there's a couple of rules to remember for loopbacks, using loopbacks for BGP, but there's one more, and this is so fundamental that it's really easy to overlook. So we're not going to do that. If you use loopback addresses for iBGP adjacencies, particularly in a simpler lab like we're doing right now, you probably need to configure a static route on each one of your routers that points to the remote router's loopback. Because if your local router doesn't have an IP route and doesn't know how to get to the address specified by neighbor, I mean, you're stuck before you begin. We've got an iBGP adjacency in progress here on the board between a couple of routers. I've got neighbor 3333 remote AS 200 on the one on the left, and that router's basically saying that's fine, but how the heck do I get to 3333? What do I do? And we're going to see all of these concepts in action in our next lab, where we create an adjacency between 1 and 3 using their respective loopback interfaces. Now, I say here in the book that the previous BGP configurations have been removed. I want to do that here live. It's not hard to do, but I do want to remind you of a quick way to get that done. So we're going to go under router BGP 100, and what I want to do, I'm going to go up till I see my 3. I might not still have that one. Okay, I don't. That's fine. Let me go in here and just change that to 3. And what you can do with this kind of command is just do a Control A, move the cursor to the front, and type no. I'm not huge on keyboard shortcuts. It's not something I do a lot of, but I really like Control A, because if you just go through your history with page up and page down, you see a command you want to negate, then you just stop right there, do Control A, the cursor moves to the front of the line, just type the word no, put in a space, and you're good. Now what I will do, and of course we're going to get an adjacency change saying, hey, you don't have that, you know that adjacency you just deleted? You don't have that anymore. Let's go up to router 3, router BGP 200, and I could have just taken BGP off of this. I could have done a no router BGP 200, but instead I'll call that command up, Control A, moves the cursor to the front of the line, type no, hit the space bar, and you're gold. That's all there is to it. During the break between videos, what I'll do is create a loopback on routers 1 and 3, 1111 and 3333, as you would expect at this point in the course, and then we'll create an adjacency using those loopbacks instead of the physical interfaces we used in the previous video. See you there.